In our unit valve, the sizes, triggers in the packages, and the sizes are specified. In fact, when the square barcode is scanned, the measurements can be seen from here. At the same time, the parts of the wafers also have their sizes and triggers indicated on them. The sensitive we focus on in the valves is the seat precision. At the seat, the grinding of the diameter and the back face are done concurrently. So, they are ground with half-micron tolerances. Our diameter tolerances have a precision of half-micron ovality. At the same time, the diameter tolerances are less 1 micron. They're done with different triggers. Here, in the valves, in terms of bench life and quality, the surface quality is made from a material that is resistant to friction and impact, and on a vehicle using high-quality diesel, it can run for 1 million to 1.2 million kilometers. Its durability is also quite high. In our grinding sensitive, especially, our surfaces are ground with great accuracy. The end faces and especially the angle points of the seat. We will examine this in detail under the microscope. There under the microscope, we are currently viewing the exact seat area of the valve. We can see the starting sensitive, the exact detail of the sealing point with the valve body. Here, between the fully contoured lower edge and the upper edges. It seals right at the midpoint, the closing point of the valve with the body. These ground surfaces are machined using top-of-the-line R-quality machines. The surfaces of the parts and the circular surfaces here are excellent. When measured for oval deformation, roundness is below 0.5 microns, meaning we achieve values like 0.2 or 0.3 microns. The roundness and lapped surfaces are excellent, and the concentricity, that is, the alignment between the seat and the valve shaft, is 1 micron. Since it has micron-level tolerances, the valve closures make at an excellent level and ensure perfect sealing with no leakage. We will go into the technical repair details of valves related to unit pumps and unit injector pumps. Especially in Scania, Volvo, Iveco, DAF, and Mercedes groups, and Detroit, we'll cover how to match the valves, how to grind them, seat grinding techniques, the trigger distances between the tappet and the valve, and the required distances between the valve and the magnetic coil. These are our primary topics. We will examine the defects in the pump seat under a microscope. After hole lapping and seat grinding, we'll measurement checks, verify the triggering, and complete the process with a leak test. The materials we need to use here, and will generally be using, include unit valves and measurement tools for different types of triggering. Our plug sets include plugs of various sizes used in Mercedes group vehicles. We also have plugs in different sizes used for Scania and Volvo vehicles. We have calibration tools at 0.01 mm sizes plate. Working with these, we'll go over the technical details. Right now, we're looking at a pump whose seat has been ground. We're examining the grinding details. Here, we're inspecting it under a microscope. To the naked eye, it looks like this. First opinion, it appears to be smooth and fine. But this pump is not a smoothly ground pump. Mistakes are usually made in these areas. Many users don't have a microscope at hand. The minor problems here are not visible. To see these issues, we need to zoom in here. Now, by zooming in here, we'll spot the flaws on the surface of the part. We zoomed into part. Alright, now we need to open it up the light. Here, there is a valve pressing point. The valve seat with the body is exactly this edge contour, meaning the point where the valve closes is at the edge. There's a certain angle between the valve and the body, and there is a point pressure there. Since it closes at a single point here, please look, there's a tear in the seat area, and as you can see, 2 tears remain here. When we tested it, this was there. The pump is leaking. Because of this leak, after the grinding was done here, missing occurs because these tiny dots cannot be detected by visual inspection. And now, make-to-lapping operations will fix the tear in the seat and carry out the leak test. First, we're introducing our unit pump lapping set. Here we have the 600-035 daily triple set. What's included in our triple set? A coarse grinding tool, a seat grinding diamond, a finish grinding tool, and also a hole lapping tool. We have 2 brushes. There is also a plastic socketed turning head. Additionally, there is a click bushing to enlarge the lapping tools. Now, the procedure we need to make here is, first, we will lap the whole of the pump. The pump hole lapping is always done first. Before doing the hole lapping, I want to explain this. Usually, when repairing pumps, people start the process using coarse grinding. Here, we also have a 4-piece set. Between coarse grinding and finish grinding, we have an additional lapping tool called medium finish. In the 4-piece set, it's the medium finish. Usually, in pump housings with minor wear, there's no need to grind too much from the seat. 0.025 triggered valve grinding is sufficient. Just grinding is enough. That's why we use medium finish and finish. When we grind the seat, we're able to restore moderately worn pump housings through grinding. When coarse grinding is used, since the diamond grains are large, it creates deep scratches in the seat. To eliminate those deep scratches, it's necessary to move directly to the finish stage. When transitioning to the finish stage, it becomes difficult to remove those deep scratches in the seat. That's why, for heavily damaged pumps, coarse grinding should be preferred. In fact, when it's extremely damaged, we even have an extra coarse diamond, which we refer to as the orange-colored one, for coarse grinding in pumps. Now, before we use the lapping set, we will first determine the hole diameter of the pump. To determine the hole diameter here, we use the valves as a gauge to identify and determine the hole diameter value. That's why this 7.005 usually in Mercedes pumps, measurements like 6.995 or 7.005 come up. We determine these using the valve as well. For example, in pumps that are not heavily worn, we take the measurement that comes out and enlarge it by 5 microns to set the lapping diameter. So now, this is 7.005 millimeter. With the valve, let's check the hole diameter of the pump. The 7.005 valve fits into the hole. Let's check from here as well. Yes! The 7.005 valve fits and it's a bit tight, even feels snug. Let's try 7.010 as well. T doesn't go in. Right now, the 7010 doesn't go in at all. We're checking both from the front and the back. It doesn't go in. Why are we checking it like this? To see whether there's any taper in the pump's hole. First, we're identifying this. If the pump bores are tapered, the valve won't operate properly in its seat. To ensure that it's proper, we need to make the hole lapping correctly. This is the hole lapping tool we'll use for the process. With the lapping tool, we'll first determine the hole diameter. The fit of the tool in the hole should be a light, snug fit. Right now, our tool is loose. You can't make lapping like this. To enlarge it, we can use 2 types of techniques. We bring it over. One way is to hold it upright like this and enlarge it using the tapping method. Another way is to rest the back part against a vise and again, enlarge it by tapping like this. We set up it. Now, the fit is actually perfect, light and snug. Yes, it's in the perfect grinding position, but I'm going to tap it a bit more to show how to adjust it. I'll demonstrate how to make the adjustment. I'm set up it again. I set up it with fixing bushes. It's tight. In this tight setup, we have an adjustment nut here. By loosening it with the adjustment nut, we need to bring it to a snug fit position. I loosened it, yes, good, right now. Should have feel a slight snugness here. It's dry right now, it's making a bit of noise. We need to spin it quickly. And then slowly pull it back. Have already done a bit of grinding, you can see some blackening in the middle area. There's nothing on the edges because the heads have about a 1% conic. From here, it's conical from the inner edge to the outer edge. The backside is also conical so that during insertion and removal, there's no binding. First, when doing lapping, we need to properly lubricate the lapping tool. We insert it into the hole well-oiled with plenty of oil. While grinding this, we'll rotate it quickly. Rotate it quickly and move slowly. Right now, I'm rotating quickly and moving slowly. Because the faster you rotate and the slower you move, it removes about 3 to 4 microns of material from the seat with each pass. And while doing this, we don't hold it like this, but with 2 fingers. Why shouldn't the tool be subjected to strain? We hold it with 2 fingers so that the tool is left to move freely on its own, because if you force it, tension can occur inside the hole, and you might run into problems. Here, we continue until it comes out the back. Yes, it came out the back well, not completely since it's conical. It was released from the load. Once it's free from the load, without changing its position, we slowly start turning it back in the same direction. We turn it back quickly and steadily. We proceed slowly. While pulling it back, we politely assist with our finger, giving it a slight pull. The process is complete. The black marks on it are from what was removed here. It shows the micron level shavings removed from the surface, and some debris has formed in the hole. We will spray it with a cleaning spray. Now let's check the valve. The inside of the hole looks like a mirror from here, and here's the microscope. No! Here we have size 7.005, and we're checking again. 7.005 fits in very easily. It moves very smoothly. The 7.0001 we're testing it, yes. The 7.010 didn't go in at all earlier. Now the 7.010 works very smoothly and nicely. Right now, 7.010 is working just fine. How do we make these tests? The size 7.010 works very smoothly inside this. When testing this, just like we tested the upper valve earlier, we saw that 7.005 went in, but 7.010 didn't. This hole also expanded by 5 microns according to Lapt, and there's a 7.010. When you lubricate it well, when we diesel it, it will become very smooth and fluid here. And we will use our 7.010. How will we detect this? Waconi are better 7.010 with 7.005. Also, when you install this 7.015, does it fit? In fact, let's test it. There are also 7.015 valves over there. When we install this 7.015 size valve, we should see that it doesn't fit in. 7.015 size, I installed it, and it doesn't even start to go in. it doesn't fit. I'm checking from the back as well. Unfortunately, it doesn't go in at all. Why are we doing this? When we look from both the front and the back, didn't the 7.015 valve fail to fit? We're confirming that the hole isn't conical inside, and at the same time, we didn't do conical grinding during lapping. Some friends make this mistake. They use the lapping tool halfway into the hole, meaning it goes in, grinds up to the halfway point, and then comes back out. So what happens then? Because it only goes halfway in, it can't properly grind the conical shape inside the hole, and that's the mistake they make. In proper lapping technique, at least 2/3 of it should come out. We'll go all the way through the hole, rotating in the same direction, and then come back the same way. At this point, the whole lapping operation is complete. We'll proceed with the second process. Now, in this pump, the seat grinding process, both the rough and finish operations, has been completed. As you saw earlier under the microscope, there was a small spot. To remove that small spot, I'll do a grinding pass using finish grinding. While performing the finish grinding, here we use our lapping fixture. These lapping fixtures are precision ground with a conical shape. The holes in these bushings are also machined to match that same conical shape. We attach it here and seat it into its place using the same system. After seating it, we click here according to the hole diameter to expand it into the hole in the system. We need to tighten it. Yes, we just clicked it. It's tightened. I'm intentionally clicking it more. To see the adjustment, right? Here we have our adjustment nut. We clicked it using the adjustment nut. Now we're loosening it. We loosened it. It turned slightly. We loosened it a bit more. We're loosening it a little further. Right here, in the seat of the multi-stage tight fit pump, it needs to be snug but smooth. This is also where the biggest mistakes happen. Our 7.010 size valve, we removed it while using the lapping technique during seat grinding. They use it excessively, but they don't enlarge it. So why do we lap it first? To remove the ovality, rust, and tapering inside that you mentioned. The hole is first drilled, and only after that should the seat grinding process be done. While making the seat grinding process, we adjust the alignment of the tool by clicking it into place according to the hole diameter, as you mentioned. After a lot of friction, we'll grind it with lubrication. This will make it even smoother. What's the biggest issue here? They don't enlarge this tool according to the hole because they don't enlarge it. Since they can't grind the seat properly in line with the shaft axis, the seat axis and the hole center don't align, and when they don't align, problems occur. Then, it can't close the seat according to the hole axis, and when it can't close, it naturally doesn't deliver the desired amount of fuel. That's why we always need to make our tool a snug fit inside the hole. We need to tap it. We tapped it, and after tapping, you can't do a dry grinding process like this here, so we take it out. Here, we have a type of oil like this. We need to lubricate it. We've lubricated it and inserted it into the hole while it's still oiled. Here, it moves with the joint it pivots. We have a jointed head here. First, we need to grind it at high speed. We need to make the grinding at high speed. This pivoting head can rotate in any direction without getting stuck. Yes, we bring it over. Here. By applying about 1.5 to 2 kilograms of pressure from the seat, we'll carry out the grinding operation. The faster it spins and the more oiled the stone is, the smoother the result will be. By grinding it here, we're also performing a finishing process. We usually hold it upright like this and pour some oil into its reservoir like this. We let the seat run freely with plenty of oil. The oil in the seat isn't going away. I keep grinding until it does. No excessive pressure, just a normal pressure of 1.5 to 2 kilograms. There's still oil in the seat. Right now, there's a small amount of oil left. Yes, the process is complete. Also, because of this diamond thin, there's no need for excessive grinding. We ground the seat and removed it again without forcing it. Yes, now we'll examine its seat under the microscope and, of course, before the examination, we'll carefully. Right now, we're going to focus on the microscope. Look, we can see the seat from here. The seat looks the same. To see the details of this, we'll focus and look through the microscope. Right now, we're looking at the seat of the pump we just ground, and we did a precision grinding. Because of coarse grinding had already been done earlier, we didn't go over it again. Yes, you can now see the grinding marks. It was ground very precisely, and there's the edge control we mentioned earlier. The edge contour will always look at the detail on the inner edge in some pumps, because the valve presses here, and some people don't pay attention to this. When looking under the microscope, they need to see that razor-sharp edge here. I'm slightly increasing the same color tone. Yes, now hear the hole, the edge, everything is smooth like a razor. There was a small bump there, and that's gone too. Now sometimes there's a pump here, and as it keeps hitting this spot, it curves the edge of the hole inward, making it concave. It is laying the hole. When it makes the hole, they grind the seat. Guys grind the seat, and when you look after grinding, you see that all these areas have been ground, including here, but on this edge, in the areas that the microscope can't reach, there will be dark marks. So when the hole bends inward, the surface shows a difference in color tone. Edges like that don't come out razor sharp. When you look at the curve with a high-quality microscope, you can see that curvature clearly. But people get misled here too. They just look and assume. The seat is perfectly clean, but there's excessive wear on one side of the pump. Because of that wear, this edge has become curved. They install the valve, it leaks. We grind the seat again, but the valve still doesn't hold. That's why you always need a high-quality microscope to inspect the Punko seat. That's why we sell microscopes. We have microscopes that provide light from the top and even from the bottom. When the light comes from below, it's easier to detect flaws in the edge contours of the hole. That's why having a microscope is our top priority when doing this kind of work. All right, now we'll move on to the next steps, matching and setting the trigger distances, then we'll check for leaks.